Hello and welcome. So, you're staring at your Cisco ACI fabric, you've got two endpoints and different EPGs, and for some reason, they just won't talk to each other. We've all been there. Well, you're in exactly the right place. In this explainer, we're going to break it all down and walk through a really systematic, step-by-step guide for troubleshooting these Layer 3 connectivity issues. We're going to turn what feels like a complex puzzle into a totally manageable process.
Okay, so here's our game plan. First, we're going to hit the fundamentals of ACI routing, just to make sure we're on solid ground. Then, we'll dive into verifying the configuration and those all-important bridge domain settings. After that, we'll run through a practical, hands-on troubleshooting checklist, and we'll wrap up by exploring some of the awesome diagnostic tools built right into ACI.
All right, let's kick things off with the foundation. To be really effective at troubleshooting ACI, you have to understand its core security philosophy. It has this unique deny-by-default approach, and honestly, that's often the root of most connectivity puzzles.
This diagram right here, this really gets to the heart of ACI policy. By default, even if two EPGs are in the same VRF and everything is set up for routing, they are completely isolated from each other. Think of it like they're in separate soundproof rooms. The only way to open the door between them is with that contract you see in the middle. It's basically an explicit permission slip, and if it's missing or if it's configured incorrectly, traffic just hits a wall, period.
Now, before we get in any deeper, let's just do a quick refresher on the core building blocks. First up, the VRF. Think of a VRF as its own virtual router. It's your Layer 3 routing domain. Next, the bridge domain, or BD. This is your Layer 2 world, kind of like a traditional VLAN, and it's where your subnets and gateways live. And finally, the EPG, or endpoint group. This is just a logical bucket you put your servers or devices into when they all need the same security policies. Simple as that.
So that brings us to our very first practical step, checking the configuration. Look, before you even think about diving into CLI commands and packet captures, you have to make sure the foundation you've built in the APIC is solid and configured exactly the way you think it is.
Think of this slide as your initial sanity check. You've got to go right down the list. Are you in the right tenant? Are your EPGs actually associated with the correct VRF and bridge domain? And the contract, have you defined the provider and consumer relationship correctly? It's a two-way street. And don't forget the physical side of things. Are your EPGs actually bound to the physical interfaces where your servers are plugged in? Trust me, a simple misclick here is so often the real root cause.
And this, right here, this is the golden rule. Seriously, don't even think about chasing down a routing problem if you're not 100% positive that Layer 2 is working perfectly. Can the leaf switch even see your endpoint's MAC address? Is that endpoint showing up in the right EPG? If the answer to either of those is no, your problem isn't Layer 3 at all. You've got to fix Layer 2 first, and then you can move up the stack.
Okay, so let's say our logical config is perfect, and we've confirmed Layer 2 is happy. Now we can zoom in on the component that actually turns on the routing inside the ACI fabric, the bridge domain. There are a few settings here that can absolutely make or break your Layer 3 connectivity.
And here's exactly where you need to look in the APIC. You go to your bridge domain, click on the Policy tab, and you'll find L3 configurations. See that unicast routing checkbox? That's the magic switch. That little box tells the fabric, hey, I want you to act as a default gateway for any subnets inside this BD. Now, it's usually on by default, but you'd be surprised. It's a critical place to verify.
This table breaks down the most critical L3 settings you'll find on a bridge domain. We just talked about unicast routing. The subnet address is pretty straightforward. That's the gateway IP your endpoints will use. Now, these last two are super important for connecting to the outside world. Advertised externally is how you tell your L3 out to start announcing this subnet to your other routers. And shared between VRFs is a powerful feature for things like shared load balancers or firewalls that need to serve clients in multiple different VRFs. Okay, this is a subtle but really important point. When you define a subnet on a BD, you really only want the fabric to learn IP addresses that actually belong in that subnet, right? The big takeaway here is to always use enforce subnet check. It's the modern, non-disruptive, and just plain better way to do this. It stops a misconfigured server, or worse, a malicious one, from spoofing an IP address and causing all sorts of headaches in your fabric.
All right, you've been through your entire logical config with a fine-tooth comb, and everything looks absolutely perfect. But traffic is still not flowing. So what now? Now it's time to get hands-on with a simple, repeatable checklist that will let you methodically track down the failure point.
Following these 4 steps, in this order, will save you so much time.
Step 1, check the physical layer. Is the correct VLAN even programmed on the leaf port? Step 2, test local connectivity. Can each endpoint even ping its own front door, the ACI gateway? If it can't, the problem is local, between the server and its leaf. Step 3, and this is a big one, test the actual application flow. Your contract might allow web traffic on TCP port 80 but deny ICMP, so a ping will fail even if the app works. Use a tool like Telnet to check the specific port. And finally, if all of that checks out, it's time to go hunting for drops.
And that leads us perfectly into our final section. Now we get to play detective. Let's explore the powerful diagnostic tools that ACI gives you to find that concrete proof, that smoking gun that tells you exactly why your traffic is being dropped. This way, you can stop guessing and start fixing.
This screen right here, this is your new best friend for troubleshooting contract issues. Seriously, go to your tenant, click on the Operational tab, and look for flows. You can see in real time every single Layer 3 packet that's being denied by a policy. It tells you the source IP, destination IP, the protocol, everything. This is the log that gives you that undeniable evidence that your traffic is reaching the fabric, but it's being blocked by a contract.
Now, for all of you who live on the command line, don't worry, ACI has you covered. You can get the exact same information directly from the leaf switches themselves. By running a command just like this one, you can filter those internal ACL logs for any packet denies. You'll see the same source, destination, and protocol info that you'd find right in the GUI.
So just to recap your toolkit, you've got this whole arsenal at your disposal. You can start high level with the EPG stats tab, then get really specific with the operational flows tab in the GUI, or you can go right to the source and get your hands dirty on the leaf switch CLI. You've got multiple ways to find the evidence you need.
You know, if there's one thing to take away from all of this, it's that troubleshooting ACI shouldn't be a random, panicked process. The fastest path to fixing a problem is to be methodical. Verify your config, check your BD settings, run through that 4-step checklist, and then use the built-in tools to find the evidence. It works every time.
So, everything we've talked about today has been about how to reactively find and fix problems after they've already happened. But that brings up a much bigger, more strategic question, doesn't it? How can you take these tools and this knowledge and flip the script? How can you build a proactive monitoring strategy that lets you catch these issues before your users even notice something is wrong? Now, that's something to think about as you get more and more comfortable with your ACI fabric. Thanks for tuning in.